Hi everybody, tonight we are working with radicals. So some of this should be a review for you. This information over here should all be a review for you. Keep in mind that we need to recall what like radicals are. So these are things that have the same index as well as the same radicand. So if we're looking at pairs of like radicals, these are pairs because they have the same radicand of 7 and the same index of 2. This is also a pair of like radicals, same index, as well as the same radicand. And unlike radicals would be an example where they have the same constant in the front, but the radicands are different. Okay, and this one here has the same constant, but there's no radicand attached here, so they are not like radicands, okay, or like radicals. That's important when we go to add and subtract radicals. They have to be like radicals, or you cannot add and subtract them. Okay, restrictions on variables is something that we also have to be aware of. So if it has a positive index, even index, then the radicand cannot be negative. So in this case, our x would have to be greater than or equal to 4. In this case over here, we have a cubed root. There are no restrictions for that. So first types of questions you're going to be asked to express each radical as an entire radical. So that basically means that we just want a radical sign with a radicand. So we need to move this constant term inside. And there's two ways that we can do that. The easiest thing is to take this number. We're working with a square root sign. So we're going to rewrite it underneath as a 7 to the power of 2, which equals 49. And when we multiply 49 by 2, it equals 98. Okay, same thing over here. We have a square root sign. That means that this is multiplied by itself twice underneath that radical sign. So to become an entire radical, we're going to rewrite a to the power of 4, and we're going to square that under the radical sign. Using our exponent laws, we get a to the power of 8. Then we multiply that by a to get a to the power of 9. In our last example, we're looking at a cubed root. So that means that 5b had to be multiplied by itself 3 times underneath that radical sign. So we're going to move it under the radical sign and cube it. When we cube it, we get 125b cubed, multiplying those two numbers together with our exponent laws, and we get 375b to the power of 5. We need to think about radicals in simplest form as well. So a radical in simplest form, the radicand does not contain a fraction or any factor that can be removed, and it's in simplest form. The radical also cannot be part of the denominator of a fraction, and we talked about that a little bit last chapter. So these are not simplified because they both have factors that are perfect squares. 18 can be factored into 9 and 2, 9 being the perfect square. 20 can be factored into 4 and 5, 4 being the perfect square. These are both simplified versions. The radicand cannot be further simplified. That's the simplest form it can go into. Okay, in this next example, we are going to be looking at converting each of the entire radicals into a mixed radical. So we're moving in the opposite direction we were moving last example. So there's two ways that we can do this. First way is to use the greatest perfect square factor. So we're looking for a greatest square factor for 200, and that's 100. So we rewrite 200 as 100 multiplied by 2 and get the square root of 100 multiplied by square root of 2. Square root of 100 is really just 10, so our answer is 10 root 2. Our second option is to use prime factorization. So you write down all the prime factors of 200, and then because it's a square root, that means that we're going to be removing groups of 2 to the outside. So we have 2 groups of 2. So we'll move out 1, 2. To the outside. Then we have 2 groups of 5. So we move a 5 to the outside, and we end up with the same answer of 10 root 2. For the second question, we want to convert all of these c's. We want to rewrite it as c to the power of 9. Okay, we've just rewritten it in the expanded form. And then because we're working with a fourth root, what we want to do is group in groups of 4. So we have 1, 2, 3, 4. 1, 2, 3, 4, and then a remaining c. So we can rewrite that as c to the power 4 multiplied by c to the power 4 multiplied by c. This group of 4 c's will get moved out, and we'll take the fourth root of that, which will give us a c. Same thing will happen with this group of 4. It becomes a c. And then we're left with 1c on the inside. Multiply these c's to get c squared multiplied by the fourth root c. This question, we want to try and factor it. So we're going to end up with 16 multiplied by 3. And then we want to rewrite this y to the power of 5 as a variable with a perfect square power. Okay, so y to the power of 5 can be rewritten as y to the power of 4 multiplied by y. Take out square root of 16, that equals 4. Square root of y to the power of 4 equals y squared. And we're left with 3y underneath the radicand. In this example, we're asked to order the following terms from least to greatest without using a calculator. So what we want to do is we want to convert them all into an entire radical, because then we can compare the radicands and see which one is least and which one is greatest. Okay. So the first thing that we have to do is we're going to rewrite this 13 to the power of 1/2 as a square root. Okay, and that's prerequisite knowledge here. 1/2 can be rewritten as a square root sign. Then we want to convert this into an entire radical. So we follow this method and we end up with 208. 8 root 3, we're going to move the 8 underneath the radical sign. So we write it twice to get 64 multiplied by 3, which equals 192. Then to convert 14 to an entire radical, we're going to take 14 multiplied by 14, and that equals 196. Then we're left with 202. So from least to greatest, it's 8 root 3. Then we would have this, which is 14. Then 2 root 202, and then 4 multiplied by 13 to the power of 1/2. Our last examples are looking at adding and subtracting radicals. So what we have to do is we have to simplify these into, look for mixed radicals that are like radicals so that we can add or subtract them. So in this first question here, we're going to simplify 50 to 25 multiplied by 2. We can't simplify 3 root 2. That's already in simplest form. So we just leave that. 25 root 2, though, simplifies to 5 root 2. Then we can add these together. This constant terms are what we add. The radical is basically considered a variable, okay? So if we had 5x plus 3x, it would equal 8x. Same with your radicals. You don't add them together, you just add the constant terms. Second equation is a little bit more difficult. Okay, we cannot simplify this, but everything else we should be able to simplify. So for negative root 27, we have 9 root 3. Negative root 80 becomes negative 16 multiplied by 5. And then negative 2 root 12 becomes negative 2 root 4 multiplied by 3. Square root of 9 is 3, so we move the 3 to the outside. Square root of 16 is 4. Square root of 4 is 2, so we move that to the outside. Then we have negative 3 root 3 plus 3 root 5 minus 4 root 5 minus 4 root 3. Combine our negative 3 root 3 and negative 4 root 3 to get negative 7 root 3. And our 3 root 5 minus 4 root 5 should give us negative 1 root 5. Okay, and the last question, 4c simplifies to 2 root c. 9 can be simplified by 3 multiplied by 3, so we move that 3 to the outside. Then we get 2 root c minus 12 root c, and I forgot the last step here, but in order to simplify that further, we would have negative 2 minus 12 equals 10 root c. So that is 5.1 for you. Again, there's a lot of prerequisite knowledge that you should be familiar with at this point. If it felt like I was going a little fast, it might mean that you need to go and brush up on some of these prerequisite skills.